Hello, everyone. I want to welcome you all to the Q&A with our speakers, Associate Professor Ross Goldingay from Southern Cross University and Dr. Rodney from the University of Melbourne and WSP Australia. Thank you so much for being here today. I want to start this session off by doing an acknowledgement of country. So Biolinks Alliance is proud to acknowledge the traditional owners of the places where we live and work. We recognise and respect the enduring relationships they have with their lands and water, and we pay our respects to elders past, present and future. I also want to remind everyone in this session that it is being recorded, and so we're asking people to please keep their cameras and their microphones off for the duration of the event, and know that if you do turn your camera on at any point, you may be captured. We obviously, oh, sorry, I just got a message saying someone can't hear me, but I think everyone can hear me. That wasn't all for nothing. This is a Q&A session, so we would love you all to please post your questions in the chat, and we will be going to get through as many as we possibly can in the next sort of 45 minutes or so. I'm assuming everyone here has seen Ross and Rodney's keynotes. If you haven't, you're more than welcome to please watch those on the Biolinks Alliance YouTube after the fact, but they are live on there for everyone to watch for free. So go ahead and watch those as well as a few others if you haven't seen them already. I think first what we're going to be doing is going directly to Bert Lobert. So I'm going to ask Bert, oh, Bert's not here yet. Okay, maybe we'll ask Sophie, if you want to kick off. Do you have any questions, Sophie, to kick us off?
Great talks, both Ross and Rod, or multiple talks, Rod. So practical, so many great guidelines and tremendous information there. And I think they've been watched a lot online. So I think they're going to be, very useful resources for people. So thank you for them. So that wasn't my question. Interested in chainsaw hollows. Ross, you made some comment about there being issues with installing doors on them. I've never really seen a chainsaw hollow. I'd love to hear a little bit more about the door. And just that, I thought they were a relatively simple thing. One just, found the right place to,
just pull out a chainsaw.
But obviously there's more to them. So I just wonder if you might want to sort of elaborate on that. Some of the issues with the doors.
It's a bit like nest boxes. The weak link in a nest box is actually the lid. So the lid's sort of the first thing to fail. Now with the chainsaw hollows, you just, obviously grab a chainsaw and cut your way into a tree, and you're trying to create a cavity. But the way people are normally doing them is that they have they cut a cavity and then they put a faceplate over that cavity, because you need a bigger entrance to get your chainsaw in to actually, carve out the right size hole. And then the question is, well, how do you attach that faceplate? And typically they get screwed in or whatever. So there are issues with perhaps the screws degrading. Also, depending on what the faceplate, how that's been made, whether it was pre-made or whatever, it may split and crack. And also the tree is going to grow bark over that faceplate. So at some point it's going to need some maintenance, regardless of how well it's created.
And Rodney, have you seen issues with the doors on the hollows that you've seen installed?
It really depends on the
Arborist.
the arborist and the type of hollow. And so I'm wondering whether I can share my screen.
I can get you to share your screen. Give me 1 second.
Yeah, because there's two photos of two different kinds of hollows I've just pulled up.
There you go.
And that will, okay, make sure I get the right screen. That one there. So have you got photos of two different kinds of hollows? I'll get rid of.
Yes, we do.
That. Yeah, so one of those, so there's essentially two different ways to install chainsaw hollows. The one on the with the, I guess, well, the obvious one is the narrow door, which is a piece of kiln dried hardwood that gets put into a slot, and basically you've carved out the inside. So you go through the narrow slot and then you make the hole bigger by, you know, swiveling the chainsaw effectively. That's the approach that you can use on living timber, whereas the other one is a face plate. And what will happen for the face plate is that will die eventually because, well, you carve it out of the side of the tree. If it's a living piece of timber, the rest of the tree will continue to grow, but the face plate won't. So that's only suitable on a dead piece of limb. What will probably happen for the narrow door is that the tree will eventually, the growth of the bark and the wood will eventually grow over that narrow door. And that's kind of what you want, because then the hollow is naturally forming a callus over that. The issue becomes if it completely covers the hole, the entrance hole, and then the animals can't get back in. But we haven't been doing this long enough to know, which species this happens to, how often it happens, and, whether it's a major issue or not.
Great, thank you for taking us through that, Rodney. Was that your final question, Soph?
Yes, thanks. That's great, and great to see those two illustrations too. Thanks.
No problem. We have a question from Jenny and Ewan. Jenny and Ewan, if you would like to unmute and ask your question.
Thanks, Sasha. We've had some interesting discussions on bees settling up in nest hollows and nest boxes, and whether that matters or not, because they might just eventually go away. From our experience, they don't go away from the hollows in our trees in our bush block. But we've heard various things over the years about how you can deter bees setting up hives, like putting carpet on the lids of nest boxes and things. Have either of you got any experience on how to deter bees? Because we've got a big problem on our bush property.
If I can quickly respond to that. So my experience is that where we've had nest boxes, typically the bees will depart after 1 year. I've had a couple where they've persisted for maybe 2 years. That's not to say there won't be some areas where the bees stay longer. And I guess one strategy is you could put up additional boxes so that there are sort of redundant boxes. The issue about carpet, I don't know that, well, not that I don't know. I mean, we've had boxes with carpet and it just doesn't deter them. So, that idea, it just doesn't work. I'm just trying to think other measures. I mean, obviously people get in there and treat them. So they put up cattle tags and things like that are impregnated with insecticide. We did a bit of that in the early days, and it wasn't always effective. Sometimes it worked, but typically, as I say, I mean, our experience is that when the bees sort of outgrow the cavity size, even though I have seen a couple of sort of rudimentary boxes in Brisbane where there was a huge hive outside the actual cavity itself, mostly they swarm and disappear once they outgrow that space. And over to you, Rod.
Yeah, look, I would say the same. I've often come across boxes. I wouldn't say often. There's, I guess, in most projects where we check boxes, some of them, a small percentage have bees. I've never found it to be so bad that it outweighs all the positive benefits of the project, but it does happen. So, I think what Ross said, one option is have more nest boxes than you think you need, and that lets the bees have one or two. If they're natural hollows that sometimes are occupied by bees, I'm not aware of any carved chainsaw hollows yet that have been used by bees, and I don't know whether that's because we haven't installed enough, or maybe the carved hollows are not optimal for bees. I'm not sure. Have you come across any, Ross? Any carved hollows with bees?
I don't think so. I'm trying to think whether William had one.
I don't think he did. Maybe one out of
Yeah,
50
you might
odd.
have had one, or you had some insect issue with one of them. But I mean, one of the key points is that you're going to get occupation of natural hollows by bees too. So it's not just that they're targeting the nest boxes or whatever. You're going to get a similar sort of percentage use of natural hollows in the same area. The only other point I can make is that the bees do tend to show a preference for larger cavity sizes. So the bigger boxes, so if you're putting up, you know, possum boxes or owl boxes, they will get targeted. Whereas if you've got something with a smaller cavity size, they're less likely to be used.
Yeah, it's interesting. Our problem, I guess, has mainly been with natural hollows and that, and we tend to, well, currently we're seeing probably about one feral beehive per hectare to a hectare and a half across the property, and tree hollows natural hollows are a limiting thing where we are. So yeah, always interested in ways around this problem.
I think there's going to be some landscapes, Jenny, where there's just going to be a high density of feral beehives, and it will be problematic. So, you know, you're just going to have to experiment to some extent to see what might work. But yeah, it sounds like there's a lot of bees there.
Yeah.
Yes.
Yeah.
Yeah.
Thanks very much.
Thank you, Jenny and Ewan. It's an interesting follow-up question from Kylie around density of nest boxes. Kylie, would you like to ask that directly yourself?
Sure. Thank you. Can you have too many nest boxes in a particular area? Is there any, you know, implications of that in terms of competition and creating dramas with fighting squirrel?
I think you can. I mean, you don't, you know, there is a cost with putting them up. They all cost money. So, you know, the more you put in one area, it's, you know, some of them are becoming redundant. And what we know from radar tracking studies of animals using natural hollows is that they will often utilise as many as there are in the area. So some species have been reported, including one of Rod's studies, of using a very large number because there's a very large number that are available to them. And from our work, what we've seen is that you only need to put a couple up because they need more than they typically need more than one. And I hesitated then because I've got a few boxes on my property here, and I've got a single one up the back, and that's been occupied by sugar gliders almost continuously for the last 6 or 7 years. So they've got by with just one nest box. Whereas a bit further down here, I've got a couple set up, and they've had a favoured box, and then they alternate, and it seems what's going on there is that this is a way of actually shedding their ectoparasites. So if they stay in one box for too long, the parasites build up, and if they can then move to another one. So you sort of want to allow for that. So what we tend to recommend is maybe put up, say, three. Three is sort of a bit of an optimal size, and then if you can have them spread out so that you know, animals can actually, you know, different social groups or whatever can utilize them. Whereas if you've got them too close together, you're sort of forcing animals to come into very close contact. Not that they can't deal with that, they can, but it's probably better, and you'll get better results if they're spread further apart. And also the point about you know, the density of boxes, you want sort of the same type. In some of the studies I've reviewed, you know, because of the nature of those studies, they've often put up one of each of different types. So they've included some that are, you know, say your target is a squirrel glider or something, they've often put up possum or owl boxes, which are not so optimal for squirrel gliders. So they'll get occasional use, but it's not sort of achieving the purpose that you perhaps would want it to achieve.
I would probably disagree, Ross. I think, and Kylie, I think the key thing there is, you know, this presentation's, you know, supposedly about squirrel gliders, but in a natural forest, there's probably 20, you know, certainly in northern Victoria and the southwest slopes, 20 large diameter or 20 hollow bearing trees per hectare. And if we make an assumption that each one of those trees has, say, 5 hollows, we've got 100 hollows per hectare potentially naturally occurring. And, you know, there's squirrel gliders, sugar gliders, birds, possums, there's a whole range of species that could potentially use them. So I think the only limitation really is a cost, and then you can't, if you've only got $100, you can't put up 1,000 boxes in one spot. You would want to spread them out. So I think that's, from a cost effectiveness perspective, that's probably a limiting thing. But I would be saying as many boxes as you can of different shapes and sizes for a range of different species.
Yep.
In the long run.
It gets to the point, Rod, of what the objective is.
Correct.
The objective is for targeting squirrel gliders, and,
That's right.
and we've done quite a bit of work that does support this idea that you only need a couple of nest, if you're using nest boxes. I'm not specifically saying we should be putting up lots of nest boxes, but you only need a few, and the studies that show animals are using up to 22 different tree hollows. Not every individual does that. We've done relatively long-term studies on yellow-bellied gliders in areas, and they use relatively few, even though there are potentially hundreds available to them.
Yep.
So, a given social group of animals doesn't need a huge number of tree hollows or nest boxes.
That's right. They use them. They use a lot because they can, not because they necessarily have to.
Good, thank you.
Thank you for your question, Kylie. I want to change the topic and go to Bert again. You have a question about sugar gliders upper altitudinal range?
Oh, yeah, thanks. So I sort of asked David this question too. I'm just interested in your insight, given you've spent so much time, you guys, looking at squirrels and sugars, and obviously, thinking about it a lot. At least sugars, the southern, what we're calling the southern crest species now, but more broadly, if we think of sugar gliders and squirrels, they're so morphologically and ecologically similar, certainly not identical. But what is driving the partitioning, this altitudinal partitioning between the two species? Why don't squirrel gliders go into slightly, wetter forests, even in the one landscape where they just drop out very predictably when the habitat changes, when you would think that if there's habitat there to exploit, they could certainly do it. Their cousins yellow bellies go from sea level up to altitude as well. Have you got any thoughts on what's actually what underlies this this altitudinal and perhaps geographical separation between the two species?
I'll let Rod take that first. I've got a few ideas.
Yeah, look, I don't know. It's probably diet related, and I spent a bit of time thinking about this 20 odd years ago when surveying for squirrel gliders in northern Victoria, and haven't thought much more about it. Sugar gliders are, I guess, they're more generalist than squirrels, but how that shows itself, manifests itself in their distributional range, I don't actually know. I mean, Ross, you've got some ideas. You're probably better than me at that.
There could be two factors driving it. Often when you go into the higher elevation forest, you've got yellow-bellied gliders, which are going to beat up smaller gliders. I mean, I've seen them beat up sugar gliders. I've even found a dead sugar glider under a tree that had yellow bellies and sugars in the night before. So I think there's that element that sugars may be able to coexist with yellow bellies more so than squirrels, because they're more different in size. So there's food types that are more available to them. Squirrel gliders seem to be a bit more reliant on winter flowering species. So a lot of the lowland areas are often dominated by, red gums and ironbarks that often flower during the winter months, whereas a lot of the areas where you see sugar gliders at higher elevation, even though there can be winter flowering things there, it's not to the same extent. There's often, certainly the areas with yellow bellies, it can be more of a mix of tree species, even though there are areas where there are, winter flowering species that the yellow bellies get into, such as on the New South Wales south coast, and some of those areas supposedly have squirrel gliders in them. So I think it's a mix of avoiding competition with larger species and it's a dietary thing driven by the timing of flowering of things.
Perfect.
Great.
Did that answer your question, Bert?
Thanks. Well, there's some leads there. I mean, I didn't expect, nobody's got the definitive answer, but it's just one of those little things in the back of your mind. If you spend enough time looking at the animals, you know, you just ask yourself, well, why? You know, why is it like this or why is it like that? And it's just, and it's interesting also because in some areas you find squirrel gliders are numerically dominant, especially in sort of remnant or roadside type areas, if there are any sugar gliders at all. But in other areas that look suitable, there's nothing. And you'd almost think that maybe sugars would invade those sites. But yeah, I mean, these are just the why questions that drive you to keep looking, I suppose. So yeah, thanks for your responses.
I think it'd make a great PhD project for someone. So if there's anyone out there.
And I know you had a second question, Bert. Do you want to go ahead with that one?
Sure, thanks. I'd love to, because I don't have a long history with squirrels. Just the last few years really looking, I mean, always been interested in them, but only the last few years actually going out and surveying and sort of questioning, you know, asking the why questions. But gee, the more I look and talk to people and the more widely you look, you know, the difference morphologically between squirrels and sugars in the field can be very subtle. And certainly looking at, and this will come up later on in some of the workshops, I think, but looking at atlas records and so on, you just wonder how confident we can be of the data sets. So behind that is, you know, how do we identify with confidence a squirrel glider from a sugar glider in the field? And so I'm just wondering what characteristics you guys would rely on generally, if you don't have them in the hand, to identify, distinguish between adults of the two species.
Yeah, that's a really good question, Bert. And sometimes, just to put your mind and others' minds at ease, and I'm speaking on behalf of Ross here as well, but certainly myself, I look at animals sometimes, and you hesitate to give it a definite ID because something doesn't quite look right. And so, for me, there is one definitive, I guess, character, and that is if it's got a white tip to the tail, it's 100% sugar glider. Ross is shaking his head. We'll get to that in a minute, Ross. Or maybe Sasha, you can delete Ross from the presentation.
I'll just mute him. That's the trend now.
So 99% likely to be sugar glider if it's got a white tip.
97.
97. Okay. It's about as definitive as it gets. The other ways we tell them apart is if, and it's actually a combination of characters. It's never just the one. If the body and the tail width is more or less the same, so you can't pick their bum basically from their tail, and they've got a really fluffy tail, that's more likely a squirrel glider. In my part, in Victoria and Southwest Slopes, New South Wales, if it's got a whiter chest and belly, that's typically more likely squirrel glider. Sugar gliders tend to be a bit yellower and grayer, but there's variation in that as well. There's the shape face. Squirrels tend to be a bit pointier. And I think for what I always try and do when I do camera trapping is I have a bait station that is a consistent size across projects. So you know that your bait station is, 50 centimeters tall, and that's the only bait station you use. And every bait station is 50 millimeters, not 50 centimeters, 50 millimeters, 5 centimeters or whatever. Then you can use that as a measuring stick, basically, and that helps. But sometimes you get juvenile squirrels that look like sugars and adult sugars with big fluffy bums that, make it a bit hard sometimes.
You mean within a population or between populations, Rodney?
Generally, it's between. So we've had one project up near Echuca, and it's really hard to tell them apart because you just think, oh, that could be either. And if you don't get a really good profile photo or it's an obscured photo a bit, it's like, what could it be? But it's about getting your eye in, having the animals in the hand sometimes so you can actually see them side by side on occasions, so that when you do go back to those photos, you can tell them apart more easily.
They have different calls, Bert. So if you happen to hear the call, the problem is the squirrel glider doesn't call very often.
Yeah.
Sugar gliders will call sort of most nights, whereas squirrel gliders don't. But certainly if you've got them in the hand, most of the time it's sort of relatively straightforward. If they're adults, like the adults shouldn't overlap in body weight. So if you've got an adult that's, I don't know, 150 grams plus, it's unlikely it's going to be a sugar glider. As Rod said, I mean, there's certain physical characteristics. The problem we have is that the northern segment of the range, the squirrel gliders the tail base is not quite as fluffy as it is in Victoria. And also the animals actually have multicoloured bellies. So the belly sort of transitions from sort of a bright, well, maybe a lemon yellow through to a mustard yellow. So whereas the sugars, they do tend to be, I mean, they will go through a bit of a colour range as well, but the younger ones can often be sort of a bit greyish. But certainly, yeah, the head shape, the pointed snout should be more pronounced on a squirrel glider, the tail piece. But the best thing, if you know, I get sent lots of photos and people say, you know, what's this? Is it this or that? And I'm always reluctant to be too definitive. And what I would say, you know, given that we do want to know where the squirrels are, is that if people get photographs and perhaps send them around and get people to sort of, you know, thumbs up or thumbs down, but it needs to be backed up with, you know, some animals in the hand. So someone needs to go out there and do some, you know, some trapping if you do need to verify certain locations.
Thanks.
Thank you for your question, Bert. I'm going to go to Gail Osborne. If you can hear us, Gail, let us know if you can join and go ahead and ask your question.
Now, can you hear me?
Yes, we can. Go ahead.
So we seem to be totally reliant on restoration projects where there's a community group and good people to lead something. So what happens when you've got some critical habitat, there's squirrel gliders, and there's no one doing anything? So how do we deal with potential projects where there's no one with the capacity in a community to actually take that big amount of work on? Sorry, could you hear my question?
Yeah, we heard your question. It was a good question. It's a challenge. You need some sort of local and someone that can access or speak to people that have done similar projects who could advise you about how to try and tap into some money to try and do some restoration.
I think another option is there's always a need. As you said, Gail, there's lots of bits of habitat and bits of bush around, and lots of endangered animals that need protecting and caring. And it would be nice, and I don't know who would do this or how it's done, but to be able to prioritise somehow, and that's not to exclude certain sites or species or projects, but rather bring the most important ones which will have the greatest benefit to the top of the list, so that when we do, whoever the we is, apply for funds to do work, that the most important, most beneficial projects get the funds. That's probably a DELP, you know, prioritisation sort of framework or system in Victoria, at least.
Okay, thank you, Gail. And Catherine Madden had a question about some distinguishing features as well. Catherine, would you like to ask your question?
Oh, thank you. I was just apparently a wildlife carer said that the distinguishing features between the sugars and the squirrels is the membrane, either from the finger or the hand, and you can just tell that straight away.
No,
I don't know if that's right or not, or
there won't be any difference in the membrane. These animals are very similar. Really, it's just the body size and a few other features like the head shape and the tail base.
okay, thank you. I'll let her know. We're up in Brisbane.
Yeah, greater gliders are different though. I think they attach from the elbow rather than the hand.
Oh, I thought we were talking about sugars and
yeah,
squirrels.
we were, but yeah.
Yep.
Okay, thank you for your question, Catherine. I actually have a question for you, Ross. I noticed in your keynote presentation, you talked a lot about nest box attrition. I wanted to know what your top takeaways are for longevity and low maintenance of nest boxes.
Okay, well, one of the things that we identified in the study down at Bendigo was that the attachment technique is critical. And I've seen this elsewhere with some of the box projects I've done that, you know, if the box is, depending on how it's attached, if you don't allow for tree growth, the tree's going to pop the box off the tree. So I've seen a lot of boxes in Victoria that have actually been nailed directly to the tree, either through the back of the box or through a backing board that's attached to the box. And that's going to be popped off in a few years, whereas a more common technique in New South Wales, and it's not to say it's the best technique, is to use fencing wire, and the fencing wire has a concertina section in it so that it can expand. That's not actually an infallible technique, because sometimes, particularly with a rear entry nest box, the box can sort of grip onto the trunk of the tree, so that even though, you know, there may be room for growth, expansion, the tree can still sort of pop the box. What we did in one project, and this is what was done or has been done in the studies by the Bendigo Field Nats, is to just hang the box on a large nail. So the first box project I ever did, I could see that this was an issue, and I used decking spikes and hung them on that. So that's that's one thing. I guess the other thing is whether the box falls apart. I mean, there's been a lot of work done by different people trying to, sort of reinvent the wheel, so to speak. And as I said earlier, it's really the lead and the screws and the hinges where these things come apart. And often with the projects I've done, if the lid fails, we end up just sort of wrapping a bit of wire around the lid to hold it in place. So to some extent, if you can do away with screws and a hinge, it will last longer. But I guess the point I was trying to make in my other talk was that people have shown a lot of concern about boxes falling apart within a very short period of time, and our experience is that boxes can last a lot longer. That you can go 5 or even 10 years. Some of the boxes down at Bendigo were left unmaintained for 15 years, and still more than 20% of them were functional after that period.
And I think there's some. Sorry, I was going to say there's a whole range of new, sort of 3D printed nest boxes, and someone in the chat talking about a concrete sort of. Denise McGregor is talking about a concrete kind of box. So there's a range of new techniques being trialled that may alleviate some of those issues. It also depends a bit on habitat. So if in wet forests compared to dry forests or areas with high rainfall, there'll be a greater decay rate of boxes compared to a drier landscape.
Yeah, perfect.
We've had boxes last for 15 years in Brisbane, Rod.
Okay.
Fairly high rainfall. I agree with what you're saying, but it doesn't mean that in those areas the boxes are going to need, monthly or annual maintenance. And in terms of some of these other box types, that's true. One issue I have with some box types is that I like to be able to, readily get my hands into a box to grab what's in there. Whereas with some of these sort of manufactured types, they're manufactured in a way, the only way you can really see what's in there is by putting a pole camera in through the entrance hole, which is fine if you know that these things are going to work and they're going to be occupied. But if you, you know, if you want to be able to definitively find your animals and see whether it's a sugar or a squirrel, you need to sort of be able to get your hand in there.
Yeah, absolutely. I want to switch a little bit and still talk about nest boxes, but specifically I wanted to talk about the temperature control in them. I know it's, temperature of gliders has been an ongoing thread through the conversations we've had over the last couple of days. And I actually wanted to invite Denise to expand upon your point with regards to some of those tests you've been doing with David Lindenmayer about different types of nest boxes and if that had any impact on temperature. Are you there, Denise?
Oh, sorry. Can you just say that again?
Yeah, I just wanted to ask if you wanted to, that's okay. I just wanted to ask if you wanted to expand on your point in the chat with regards to some test cases you've been working on with David Lindenmayer about some concrete nest boxes, longevity, and especially in relation to temperature control of those, as we know that nest boxes do record higher temperature than natural tree hollows.
Yeah, so as part of my PhD, I actually had eye buttons in about 80 hollows from North Queensland through into Victoria, through all my sites, and as well as in the canopy outside, close to the hollows where we saw gliders perching at night, so we could compare the two temperatures there. And so we could look at the temperatures they're experiencing inside the hollows as well as outside, and to look and see if there's a lag that maybe meant that the temperature inside the hollow never quite reaches the outside temperature before it starts to come down. So we're still analyzing that data, but it kind of also went along with the metabolic testing I did of gliders, where we looked at thermal capacities and how they differed between northern populations and southern populations. So my PhD was really looking at the drivers that drive the body size variation we see as many species tend to get smaller as you move toward the equator. Unfortunately, with greater gliders, my study showed that it looks like there are 3 species. So that sort of was interesting for my PhD, since I was looking for what drives a single species body size variation. But so anyway, we're using a bunch of that data now in the new project. And so we plan to look at that hollow data when we try to model some new designs for nest boxes. And we're working with WWF, who has a grant to do that as well. So it's still a bit early, and we hope to be able to use ANU and some of the science and engineering, specialties there to help us design boxes. But we are wondering if it's possible to even have boxes that may be slightly cooler than what they're experiencing in the habitat, which might help to buffer them against, extreme events. Although, as Kara's really into the research about nighttime temperatures, because they have to be outside during those temperatures, and those look like they're increasing. So anyway, so it's really early in that, but I know that they're looking, definitely, we're talking about looking at some different designs and being able to test those designs in the lab, in the climate controlled rooms, both with and without gliders. So.
Thanks, Denise. And Ross and Rodney, do you have any follow-up comments to that?
Yeah, I think it's really interesting that we are still having discussions now about the design of nest boxes, despite the fact that we've been using them for 40 odd plus years. And I think one of the things I tried to stress in my presentation about improving our knowledge is we're all out there putting up boxes, but if we can get a little bit smarter about what the design of those boxes and working together and setting it up as an experiment. So rather than just putting up what we think is the best box or what someone else thought was a good design, but actually, maybe having 2 or 3 kinds of boxes in close proximity to each other, and then it could be a box and a chainsaw hollow and another kind of box, a concrete one and a wooden one and a carved hollow, whatever it might be. And then we put out 20 or 50 of those triplicates, we can actually answer some of these questions that we're still discussing today with some reliable, strong evidence in some years to come. Otherwise, the thing that I'm concerned about with carved hollows is we're all out there doing our thing, putting in different designs slightly differently, and we're hoping that in 10 years' time, somebody can get enough information to put together a really reliable design or suggestion for how we should be doing carved hollows. So my plea there is, let's work together, let's collaborate across borders, across jurisdictions, whatever it might be, and design this like an experiment, and we'll get good, strong evidence of what best practice is going forward.
Absolutely. Go ahead, Ross.
The comments I would make is that it seems nest boxes are a little bit like wheels. People want to keep reinventing them. I think we have fairly good information about the design elements that we need to target certain species. Certainly not all species, but some species like these small gliders, we know the key design issues. Certainly there's been research done into what can we do to have a design that creates a slightly cooler box. So, Steve Griffiths and others have done work looking at different paints. We know that positioning boxes on different sides of a tree can create a 1 or 2 degree buffer. We can use concrete boxes. We've done that. It's been done widely in North America. But the question is, do we really need to do all that? Because we've also done studies, like we did a 10-year study in Southeast Queensland. We had squirrel gliders occupying boxes continuously. And, there was more than 100 breeding events, it might have been 60 odd breeding events. So the question there is, do we need a different design nest box in that particular area? And I don't think we do. The question of, should we be concerned about temperatures in nest boxes? I think we do. We need to keep looking at that. But some of the information we have so far, so I've looked at this with some of my sites with squirrel gliders and also pygmy possums, and it doesn't seem like there's an issue there. With Karen Thomas down at Bendigo, we tracked sugar gliders and phascogales in nest boxes over the summer of, was it 2018, 2019, and we had, trying to think now, we might have had 10 days where it went to 45 degrees or above, 10 days over 40 degrees, one day when it went to 45 degrees. And we followed animals that we knew that they were in the boxes, and we had data loggers in there. And even though we were expecting the worst, there was actually no mortality, which is quite surprising. And the surveys of the boxes through those broader areas demonstrated there was no decline over the 12-month period that we did the surveys. So it's not to say we shouldn't be worried about heat waves. I think we should be, but and we need to do more research. But I think we're perhaps trying to reinvent the wheel when we don't need to. And maybe Rodney's made some good points about chainsaw hollow. So it may well be that the chainsaw hollow is the way to move forward with, because we know from the work that Steve Griffiths and others have done that those hollows are more stable and cooler throughout the year. So maybe if there is a temperature issue, that could be the way to go. But one of the other points I would make in regard to nest boxes is that they offer a lot of flexibility. So some of the sites I've worked at, you have the flexibility where you can move these things around. I've done a study with pygmy possums where I put boxes in and then I took them out. You have that flexibility with nest boxes, which you don't with chainsaw hollows. And there are certainly some areas in the box ironbark forest where the tree diameters are very narrow. So even if you go in there wanting to put in, 20 or 50 chainsaw hollows, there's not often that many trees you can put them into, where those trees may not fail at a later date because the trees are just not big enough. So I think there's still uses for nest boxes, and they really offer a lot of flexibility to address a lot of research questions.
Thank you so much. Some really good points, from both of you, Rodney and Ross, and I've got a few comments in the chat as well, so everyone check those out. We're out of time for this session, so I just want to thank you both again for your valuable input. another great conversation. So I really appreciate you taking the time, and thank you as well to Jerry Alexander, who's also been answering some questions in the chat as well. So thank you again, and I hope everyone enjoys the rest of the day.